In this tutorial, we want to get a sense of how Avogadro's constant connects to the mole, and really we want to dig deeper to see what is the mole, or what is the mole as it relates to chemistry. And so the mole is an amount equal to 6.02 times 10 to the 23, and to see that in expanded version down here, the mole, 1 mole of something is a lot of stuff. Now, the person here, this is Amedeo Avogadro, and this is the person credited with coming up with Avogadro's constant, which is which is equivalent to 6.02 times 10 to the 23. And so again, it's the 6.02 times 10 to the 23 is not itself a mole. It's just the number of things that are in a mole. So anytime in chemistry that you have 6.02 times 10 to the 23 atoms, or molecules, or formula units, as we'll hear is kind of the term used when we're talking about ionic compounds, anytime you have that many things, you have 1 mole of that stuff. And a concept that we will explore later is that if you have 1 mole of something, 1 mole of water molecules does not weigh the same as 1 mole of iron atoms. And so moles of material, moles of stuff, have different amounts, or have different masses, I should say. And really, I think the best way to think of a mole is kind of like here, the chemist's dozen. And so if you have 1 dozen eggs, that you've got 12 eggs. And so if you had 1 dozen oxygen molecules, you would have 12 oxygen molecules. The difference between oxygen molecules and eggs, though, is that eggs are much, 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 much bigger. And so it's reasonable for us to talk about a dozen eggs. But a dozen oxygen molecules is such a tiny, tiny amount of oxygen molecules, it doesn't really have much meaning. And so the mole is the chemist's dozen because when we talk about a mole of oxygen molecules, which is equivalent to 32 grams, that allows us to talk about something on a scale or a size that has more meaning to us. And so the mole is an easier way to count large numbers of things. And so coming up in future lessons, we are going to make some connections, or we're going to see how we can do calculations using not only to find the number of moles, using the mass and the molar mass, as we'll call it, but also to find the number of moles using Avogadro's constant given above. So in the second part of this tutorial, I'm just really going to reinforce some of the ideas that were mentioned or that were shown in that infographic that we just looked at. And so we talked about Avogadro's constant being being equivalent to 6.02 times 10 to the 23, and that is the number of things in a mole. And where that number comes from is that there are exactly this many carbon-12 atoms in 12 grams of carbon-12. And so Chemistry Cat has a real cracker of a joke for us here. But if you were to cut an avocado into that many pieces, I'm pretty sure that you would be cutting avocado for probably all of your life and then some. The Avogadro's constant is a huge, huge number. To give you a little bit of perspective on that, if you had a mole of hockey pucks, it's equal to the mass of the moon. Or if you had a mole of pennies and you divided it up amongst Earth's population, each person would have about 1 times 10 to the 14 pennies. Now, if you spent this at a rate of so if each person spent this at $1 million a day, you would use up each person's individual wealth in 3,000 years. But there's one small issue with having a mole of pennies on the surface of the Earth, and that is that all of the copper coins would cover the Earth's surface to a depth of 400 meters. So we'd literally drown in our own wealth, of pennies. And in the infographic, we talked about really what the mole can do for us. And so it's a way to deal with huge numbers. And we can figure out how many things there are in a sample by measuring the mass of that sample. And so just don't forget that the mole it's an amount, or you can think of the mole as a unit that is used in chemistry to indicate a specific amount. Just like a dozen is used to indicate 12, a mole is used to indicate 6.02 times 10 to the 23 things. Finally here, once we have done some work with the mole and done some introductory calculations to the mole, we're going to start seeing applying this concept of the mole in chemical equations. So previously in a chemical equation we would assume that 2 is indicating just the number of molecules, and this 1 indicates 1 oxygen molecule and this 2 indicates 2 molecules of water. But we're also going to see that the 2 and the 1 and the 2, so the stoichiometric coefficients, or just the numerical coefficients we'll call them, can also be used to represent the ratio of moles. And so what this says is for every 2 moles of hydrogen that react with 1 mole of oxygen, 2 moles of water are produced. And as we're going to see when we study stoichiometry, that's going to be a hugely important idea. And in honor of the work of Amedeo Avogadro and the concept of the mole, and just to celebrate chemistry in general, there is Mole Day. And I would say the original Mole Day occurs on October 23rd every year, and it typically starts at 6:02 a.m. and ends at 6:02 p.m. And a great way to celebrate Mole Day is with 18 milliliters of water. And so the next time I see you, I'm going to ask you why it is that Mole Day is on October 23rd, why it starts at 6:02 a.m. and ends at 6:02 p.m., and why celebrating with 18 milliliters of water is a great way to celebrate it. One other thing, is there another day of the year where it might make sense to also have a Mole Day celebration?